So here I'm saying x is distributed normally and that 90 is the mean and the variance is 5 squared, meaning the standard deviation is 5. And here we're saying find the probability that x is less than 95. Now to help us visualize this, let's get a graph. Okay, so we've got a bell-shaped curve. Now you should know the mean is 90, so that goes in the middle. And then you can have the rest of the numbers, but 90 is in the middle. Now if you were sketching this and you don't need to sketch it and you want to know what value to go up to, you should go roughly up to 3 standard deviations. So we know 90 is in the middle and 1 standard deviation is 5. So 3 standard deviations is 15. So just go up to 15 above 90, which is 105. Because the curve gets very close at that point. Because remember, most of the area is within 3 standard deviations. And this is the area we need to work out. And using those values you memorized, you can work out this area. So if you'd like to start having a think about it, go ahead. So one thing you should notice is that 95 is exactly 1 standard deviation above 90. This area here is within 1 standard deviation of 90, between 85 and 95. And from the notation in the top right, you should know that 1 standard deviation is 5, because written in there is the variance 5 squared. That sigma squared is the notation for variance, and sigma by itself is standard deviation. So our standard deviation is 5, and we have this area which is within 1 standard deviation. And of course, the area of that is 0.68. Now, if you take one side of it, of course, the area is half of that amount, 0.34. So we know this part of the area is 0.34. Now, what's the other side of the area? Because remember, we want from 95 all the way down forever. So what is the other part? And you have answered it earlier on in this video. And hopefully you should have said 0.5 because it's half of all of the bell-shaped curve. And now you can probably find the area to the left of 95. Add those two values up, you get 0.84. So in essence, you've worked out what the question wanted. The probability that x is less than 95. And remember, probability and area are the same thing here. So that wasn't too bad, was it? So there's only 3 values you have to memorize, and you have to get used to this notation here. Inside the brackets, we have the mean followed by the variance, which is the standard deviation squared. Okay, so here we've got another question. However, it's a little bit more trickier. Now we want the area to the left of 55. Now you can see the mean is 50. And the standard deviation, you should say, is 3. Because 3 squared, remember, is the variance. So the standard deviation is indeed 3. Now 55 is not quite exactly 1 standard deviation above 50, is it? Nor is it 2 standard deviations above 50. It's something in the middle. And we don't have any memorized values for that. So we can't use what we've learned so far to answer this question. And I wouldn't make you memorize loads and loads of values because really and truly, there will be infinite amounts to memorize. You can be within 1 standard deviation, within 1.5 standard deviations, within 2 standard deviations, within 2.5 standard deviations, and it goes on. So you can't keep memorizing values. And this one is clearly not within 1 nor within 2. So those values we learn won't help us here. So this is the area the question wants us to work out. The area to the left of 55. Now I've got some good news for you. Working this out is very easy. You simply just use your calculator. What you need to do in your calculator is go to the normal distribution function on your calculator, and it might be different for different calculators. And on the calculator, it's going to ask you the mean, the standard deviation, and the x value. And whatever x value you put in, it works out the area to the left of it. So if we put in 55, it automatically only tells you the area to the left of it, which is good because that's what we want. We want the probability of x being less than 55. Now, lots of calculators want 2 values within which you want the area. Now, of course, we want the area between 55 down to forever onwards. But how do we say that? So what you can do is put the upper bound as 55 and the lower bound as a value to the very far left of 55. It could be minus a million or minus a billion. Now, to be honest, once you've gone 4 standard deviations to the left of 55, you're not missing out much area. Because remember, the curves got really close by now. So if you do area between 55 and, for example, 0, you should be comfortable. You've gone many standard deviations to the left of 55. And the area you left out, which is to the left of 0, is insignificant. Even if you did between 55 and 30 as upper and lower bound, you're still pretty comfortable. And you can try it and test it out. Do areas between 55 and 40, 55 and 30, 55 and 0, 55 and minus a million, 55 and minus a billion. And you'll notice they don't make much difference. People get a bit worried and put a really, really far left number. I've seen people put minus 10 to the power of a really big number, just in case they miss out a small amount of the area. But you need to be smart about it. So go ahead and try putting this into your calculator. And I'm going to show you how to do that on my calculator. And we get 0.95221. Okay, so we've got 3 more questions here. So in the first one, we've got x is distributed normally with the mean as 8 and the variance as 2 squared, meaning the standard deviation is 2. And we want the area to the left of 5. So we want the probability of being 5 or less. Now, 5 is not a beautiful 1 standard deviation below 8, nor is it 2 standard deviations below 8. So it's not one of those questions where you're going to use those memorized values. You're going to need your calculator for this. And to be honest, you'll always have your calculator. So even if you hadn't memorized those values, you'd be able to answer any questions on them. So this is a rough idea of the area we're looking for. But of course, you're going to just simply put it into your calculator. So what are we going to put into our calculator? Of course, we'll put the mean as 8, the standard deviation is 2, and the upper bound is 5, of course, we know that. But the lower bound, how far do you want to go? If you want to go crazy, go to minus 10 to the power of a big number if you like. But if you did the upper bound as 5 and the lower bound as 0, you're pretty safe. But if you want to go crazy with it, go for it, no problems. The answer will still be the same, so long as you haven't kept too close to 5. If you did between 5 and 4, then you've missed out a lot of area. So let's go ahead and put that into your calculator. And you should have got 0.06681. Now, I'll give you a moment and try the next question. Okay, so the next question says x is distributed normally, the mean is 23, and the standard deviation is 5 here. So this time it wants the probability of x is more than 30, meaning the area of 30 and more. Now this is going to look slightly different on the graph, because of course 30 is above the mean. So it wants this area here. This is a very rough drawing and you don't need to always do this drawing. So you should know it's very similar to the previous question, but this time the lower bound is 30 and the upper bound is going to be a really big number to the very right of 30. So again, you can go crazy and put 30 to a billion, 30 to all the way up to 10 to the power, a very big number. But if you've gone a few standard deviations above 30, you're comfortable. 30 to 45 is more than enough. So put the mean as 23, the standard deviation is 5, and the lower bound can be 30, and the upper bound, a big number. And you should get 0.08076. So here we've got the last question. So if you want to try it, if you'd like to try it, pause the video and have a go. So it says x is distributed normally, the mean is 120, and the standard deviation is 4 here. And it wants the probability of being between 110 and 125. And to give you an idea about that, it's this area here. Both values are on either side of the mean. For this question, it's actually easier because you can clearly see what the lower bound and upper bound is. There's no trying big numbers like the previous questions. So simply just put the mean in as 120. and the standard deviation is 4 here. And the lower bound is 110 and the upper bound is 125. And you should have got 0.8814. We will do the other parts of normal distribution in another video. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.